All right, good morning, ladies and gentlemen. Today, Tuesday the 19th, I will be going over review problems from units 1 through 3. And these are the review problems that will help you with being prepared for the final exam. All right, so I'm gonna try to keep this super quick, trying to make this super fast. I'm gonna use this format so that I have more access to things to be able to make these problems, work out these problems. All right, so the first question considers this function in explicit form. So this function is in the explicit form. Select the equivalent recursive form. So this was from unit 1. In order for you guys to be able to do this, I need you we need you to first see what are restrictions. So this function has a restriction where n has to be greater than or equal to 1. And all of our recursive functions have the restrictions that n has to be greater than or equal to 2. So we're going to follow these restrictions here. So in order for us to be able to do this, we need to see what our answer choices have. So in this case, it's telling us that f of 1 is equal to -1. That means whatever our function is, if we were to plug in a 1, our answer solution would be a -1. So for example, if I were to plug in a 1 right here, so if I were to have f of -1 is equal to 3 times -1, I don't know why, no, positive 1, I'm sorry. So positive 1 minus 4, so then we would get 3 times 1 is 3, 3 minus 4 is equal to -1. That's how we ended up getting those answers here. And if I were to plug in a 0, 3 times 0 is 0, minus 4 will be -4. Now, so we have to follow these restrictions. So n has to be any number greater than or equal to 2. So in this case, the reason why you want to select 2 as your number that you're going to plug in to verify is because we have this function that f of 1 is equal to -1. So I'm going to just go one by one to see which one of these will be the equivalent recursive function of this explicit function. So I'm going to substitute 2 for our n. So it's going to be f of 2 is equal to f of 2 minus 1 plus 3. And then we know that f of 2 minus 1 is equal to 1 plus 3. And we know already that our answer to f of 1 is equal to -1. So I'm going to substitute that and get -1 plus 3. And we get our answer 2. Okay. Now, before I continue with the rest of the problems, since I substituted 2 for n, I'm going to substitute 2 for n over here. So I'm going to move on from here. So I'm going to go f of 2 is equal to 3 times 2 minus 4. And then 3 times 2 is 6. 6 minus 4 is equal to 2. So this gave us the same solution as when I plugged in the 2 for this recursive. So that's a good indication. So now let's try letter B. So letter B says that if I were to plug in f of 2 or a 2 for the n, I would get f of 2 minus 1 minus 4. And we know that 2 minus 1 is 1. And f of 1 is -1 for part B. So -1 minus 4 will give us an answer of -5. And when we plugged in the 2 to our explicit for equation, we ended up getting 2 as our answer. In this case, we get -5. That means B is not it. Now, C, I want you all to notice that they gave us the answer to f of 0. Now, f of 0, we get f of 0 by plugging in a 1 for n. So the only way we get f of 0 is if I were to say f of 1 is equal to f of 1 minus 1 minus 4. F of 1 minus 1 is 0, which is what I want because now I know I can substitute that in for -4. I forgot to drop down this 4. And then I end up getting my answer to be -8. So the only problem with this is that 1 is not a number bigger or equal to 2. So automatically I cannot substitute a 1 for this one. So this is automatically not these are not our answers because they want us to find they gave us f of 0, but we can't find f of 0 because it does not satisfy this restriction. So our answer to this problem is A. Okay. For number 2, it's similar, but now we have a sequence. So consider a sequence whose first 5 terms are 6, 12, 24, 48, 96. Then select the function that can be used to define and continue the sequence. So the n represents the term, okay? So in this sequence, we have the first 5 terms. So this would be term 1, term 2, term 3, term 4, term 5. In other words, this would be your n. These would be your n values, and these would be your f of n values. So that means that if I were to plug in a 2 to these equations, the equation that is the correct one will give me 12 of them answer. If I were to plug in a 4 to inside of the n, my answer will be 48. And the way you kind of do these problems is you kind of have to kind of guess and check. So I'm gonna guess, I think it might be this one. So I'm gonna say f of, and I'm gonna just choose 3. So f of 3 is equal to 6 times 3 squared, and 6 times 3 squared, 3 times 3 is 9. And then 9 times 6 is 54. So when I plugged in the 3, did it give me 54? No, it gave me 24. That means B is not it. Okay, and then you would work all these out as best as possible. And so the answer for this one is, all right, so let's work it out. I think it's C. So let's do C. So f of, I'm gonna select 3 one more time. F of 3 is equal to 6 times 2 to the 3 minus 1 power. I substituted a 3 there. So I guess 6 times 2 to the 3 minus 1 is 2. And then 6 times 2 to the second power, which equals to 4. And then 6 times 4 is 24, which is what our value equals when I plug in a 3. And then if you were to plug in a 2, here 2 minus 1 is 1, 2 to the 1 power is 2, 2 times 6 is 12. So your answer is C. Okay, that's how you do that problem there. For this problem here, it says determine if the sequence is arithmetic. If it is, find the common difference. All right, so you all learn how to determine if a sequence was either arithmetic, or geometric, and the difference between arithmetic and geometric sequences are very simple. In arithmetic sequence, you have a pattern that is adding, and in a geometric sequence, you have a pattern that's multiplying. That's a dot. So in this case, we have, we start off with our initial term. So negative 19, then it goes to negative 9, then it goes to 1, then it goes to 10. So as you can see, these numbers are increasing. They're getting bigger because you're going from a very, I guess, a small negative all the way to a positive number. So how much is it increasing by? It's actually increasing by 10. So these are being added by 10 the entire time. So in this situation, we would say that this is an arithmetic sequence, and they want us to find the common difference. So the common difference is equal to 10, because that's the number that we're adding by, okay? This example here, determine if the sequence is geometric, and if it is, find the common ratio. So remember that geometric means that the pattern is multiplying. So in this case, are the numbers adding, or is the pattern adding, or is the pattern multiplying? Well, we start off with our initial term 1, then it goes to 6, then 36, then 216. So clearly we're multiplying by 6. 6 times 1 is 6, 6 times 6 is 36, 6 times 36 is 216. So we would say, yes, it is geometric, and our common ratio, so R is equal to 6, okay? And I forgot to mention that when you use common difference, you use the variable D. All right. The next one is graphing rational functions. So a rational function is basically when you have a polynomial divided by another polynomial. So here we have 1 over x plus 1 minus 1. So the first thing that I want to talk about or remind you all how to do this is we need to find, whenever we have a situation like this, we need to find our vertical isotopes. Now, you all have learned that but it has been a long time, so I do understand that. So a vertical isotope is a number in these rational equations that will make the denominator of this fraction 0. So and that number does not exist as a solution to this rational equation. So what that means is that we need to find that number that will make this denominator equal to 0. So one way to do that is we get the denominator and we make it equal to 0. So x plus 1 is equal to 0. Then we solve for x, so minus 1 both sides. So we get x is equal to -1. This means that x cannot equal to -1, because if it were equal to -1, then -1 plus 1 will make the 0, which will give you an undefined solution. So when we're talking about the graphs, I'm going to do a very quick sketch of a graph. Basically, -1, -2, -3, 1, 2, 3, 1, 2, 3, 4, 1, 2. Basically, what this means is that at -1, we have a vertical isotope, meaning our graph will never ever cross this line, because this line does not, this value does not exist as a solution to this equation. Now, we also learned about horizontal isotopes, but because it was a very long time, the next thing that I want you to do is I want you to substitute 0 to be able to determine where in this equation will this graph cross x equals 0. So basically what I'm doing is I'm plugging in 0 for x, and then I have 1 over 0 plus 1 is 1, 1 divided by 1 is 1, 1 minus 1 is equal to 0. So this graph, the graph of this function, will cross 0, 0. So we'll cross this point right there. And this would be our vertical isotope. Okay? So what that means is that one of these answer choices needs to have a vertical isotope at -1 and has to cross the point at 0, 0. So this one has a vertical isotope of +1. Okay, this one has a vertical isotope of -2. This has a vertical isotope of 0, and this has a vertical isotope at -1. And this graph does cross 0, 0. So your answer is D. Okay, so those are just ways for you to be able to determine your solution for graphing this rational equation. All right, moving on to the next problem. So here they want you to solve a rational equation. Now, whenever you have two rationals equal to each other, you all might have learned the trick, and the trick is you cross multiply. Okay. So when we cross multiply these rational equations, we multiply 2 times x is equal to 2x equals, and then what I always like my students to do is put parentheses around these binomials, and then we end up getting x plus 1 times x plus 6. All right, so then we get 2x is equal to, and here you have to double distribute, x times x is x squared, x times 6 is 6x, 1 times x is 1x, and then 1 times 6 is 6, and then we combine like terms, so we get 2x is equal to x squared plus 7x plus 6. And then finally we have, since we're solving for this equation where we need to subtract both sides by 2x, so these will subtract out, we get x squared plus 5x is equal, plus 6 is equal to 0. Now, since we're solving, we need to solve this. And I noticed that if I multiply 3 times 2, that gives me 6, and then 3 plus 2 is 5. So this is a factorable problem. So this equation can be factored as x times x. We know 3 times 2 is 6, and then 3 plus 2 is equal to 5. And we use the zero product property, which tells us that our values would be, both of these factors will be equal to 0. And when we solve this, we subtract 3 to both sides. So we get x is equal to -3. And then when we subtract 2 to both sides, we get x is equal to -2. Okay. And those are your solutions. X equals -3 and x equals -2. All right, so moving on to the next question. Here they want us to add these polynomials, and because these polynomials are simply just adding, all we have to do is combine like terms, and you always have to combine the like terms of the exponents and the variables. So these both have an n to the fourth power. That means I can add 4n to the fourth power plus 5n to the fourth power becomes 9n to the fourth power. And now we can add the next biggest term, which is third power. So 4n to the third power plus n to the third power. Remember, there's always an invisible 1 in front. So 1 plus 4 equals 5. N to the third power. Then we go to the next lower exponent, which is second power. Negative 6n to the second, but there is no other negative 6n to the second. So that just stays as negative 6n to the second power. Then we don't have a regular n. Then we have our constant plus 7. So 7 will go here. And that would be your the sum of these two polynomials. Okay. Now in this problem, we are subtracting polynomials. So in order for us to be able to subtract these, you need to always make sure that you distribute the negative to all of the terms inside of the second polynomial. So we get x to the third power minus 4x plus x to the fourth power minus 8x plus x to the fourth power minus 1. Okay, minus 1. And now we combine like terms. So x to the fourth plus x to the fourth becomes x to the 2x to the fourth, sorry. 2x to the fourth power. Then we have a regular x to the third power. We don't have another third power. We have negative 4x minus 8x becomes negative 12x. And then finally we have this minus 1. And then since nothing else can be combined, that would be our answer for this problem. Okay. And for the next problem, we are multiplying polynomials, which means that the parentheses are next to each other. So we're going to multiply. Now we multiply these using the area box method, which means that we have to draw a 3 by 3 box, or at least this is how I tell my students. So I have 3x squared minus x minus 1, and here I have 2x squared minus 2x plus 1, and now we multiply in order for us to be able to get terms inside. So the inside terms would be 3 times 2 is 6x to the fourth power. 2x squared times negative x becomes negative 2x to the third power. Negative 1 times 2x becomes negative 2x to the second power. And then we move on to this column. So 3x squared times negative 2 becomes negative 6x to the third power. Negative x times negative 2x becomes positive x squared. Negative 1 times negative 2 is equal to 2x. And finally, 3x squared times 1 equals 3x squared. Negative x times 1 equals to negative 1x. Negative 1 times 1 equals to negative 1. Now that we have that, we can go ahead and combine like terms. And remember that when you combine like terms, you always combine diagonally. So these are all third powers. These are all the second powers, and these will all combine. And these are all just the regular x's. And then the two terms in the corners, top and bottom, right, left corner, don't get added with anything because they just have x to the fourth power. So negative 2x to the third minus 6x to the third becomes negative 8x to the third. Negative 2 plus 2 is 0, plus 3 is 3, so we get 3x squared. 2x minus 1x equals to 1x. And then finally the minus 1, the constant term. Okay, and that's how you multiply polynomials. A 3, this would be considered a 3 by 3 polynomial. Okay. All right, so we also learned how to convert rational exponents. So if we have a fraction that's an exponent, we learn that those exponents become radicals with power. So one way to convert this, remember that the 3 is the root. The 216 goes inside of the radical, and then we have second power. And then you can also rewrite this as parentheses, cube root of 216. and then to the second power, which means we can simplify this further by taking the cube root of 216. So the cube root of 216 means what number times itself 3 times give you 216? And that number is actually 6. So then we end up getting parentheses 6 squared, because 6 times 6 times 6 equals 216. And then this squared, which just follows, and then 6 squared equals 36. So this is how you would convert this to a radical and then simplify the radical to get your answer, your simplified form. The next problem is an operation on complex numbers. So remember that complex numbers add the same way as polynomials add. So -2 minus 1 becomes -3, and then 2i plus 7i is equal to 9i. And that would be your simplified form for those two complex numbers. Now, when you're subtracting, remember that you always need to distribute the negative. So you end up getting 2 minus 6i minus 8 plus 8i. And then we combine the terms. 2 minus 8 is equal to -6. -6i plus 8i becomes plus 2i, or positive 2i. And then the last complex number here, we're multiplying, and you can tell it's multiplication because the parentheses are next to each other. There's 2 ways you can do it. You can distribute, or you know what? Let's organize this multiplication using the box area method. So 3 goes there, 7i goes here, 6 goes there, -2i goes there. 3 times 6 is 18. 3 times -2 is -6i. 7 times 6 equals to 42i. And then 7 times -2 equals to -14i squared. Okay, so we combine the two terms in the center. So we get 18, 42 minus 6 is equal to 36. So plus 36i. And then minus 14 I squared. But remember that I squared is the same thing as saying -1, or it can be simplified to -1. So we get 18 plus 36i minus 14 times -1. And then we get 18 plus 36i plus 14. And then we add the 18 plus the 14 to be able to get 32. So your final answer would be 32 plus 36i. Okay. All right, we have like 2 more problems, I believe. Yes, we do. So here we're solving this equation. And this is called a radical equation because we have a square root. So in order for us to be able to solve this, we need to isolate the radical. That means this -10 needs to be moved to both sides by adding 10 both sides. These 10s subtract out. We get square root of 1 minus 5k is equal to -6 plus 10 equals to 4. Now, this is the part where you all have to remember the rule. So the rule is if you have a square root, how do we get rid of the square root? We get rid of the square root by squaring both sides, because the square and the square root are inverse operations of each other. So we end up getting 1 minus 5k is equal to 16. We subtract 1 to both sides. We get -5k is equal to 15. And then we divide both sides by -5. These -5s divide out, so k is equal to -3. And that would be your solution for this problem here. Okay. And finally, the last one, solve this equation using quadratic formula. So one more time, the quadratic formula is x equals -b plus or minus square root b squared minus 4ac, 4 times a times c, all over 2 times a. And now we can go ahead and start our substituting. So remember that the x squared has the a value, the linear term, which is just the x, has the b value, and the constant, or the number with no x, is the c value. So -b would be negative parentheses times -4 plus or minus square root of 4 squared minus 4 times A. A in this problem is the 5. And then C in this problem is the 1. All over 2 times A, which is 5. Then X is equal to negative 4 plus or minus square root. 4 times 4 equals 16. Negative 4 times 5 is negative 20 times 1 is negative 20. All over 5 times 2 is 10. Then we get X is equal to negative 4 plus or minus square root of 16 minus 20 is negative 4. All over 10. I will continue over here. So we get X is equal to negative 4 plus or minus. The square root of negative 4 is equal to 2i. Okay. Remember that the square root of a negative number always gives you the imaginary number I. And the square root of 4 is just 2. All over 10. Now, the cool thing here is that we have a 4, a negative 4, we have a positive and negative 2i, and a 10. All of these can be reduced by dividing everything by 2. So if I simplify this by dividing everything by 2, I get X is equal to, negative 2 plus or minus I all over 5. So your two solutions are X is equal to negative 2 plus I divided by 5, or X is equal to negative 2 minus I all over 5. And those are your two solutions. All right, so you guys do have a cool down, but the cool down is more like a practice. You have basically practice problems like these problems here. If you're working on an Edpuzzle video, the Edpuzzle video will be made for you to be able to skip. That way you all don't have to, like if you already remember how to do a problem, you don't necessarily have to see the entire video. All right, so with that being said, good luck on your studying for your final exam, and hopefully these questions, these problems and example problems help you guys out. Have a good day. Take care. Bye.